Okay, hello everyone in new video. So we have reached part 5 of chapters 5 and 6 for grade 8 students. Now in this one we are going to solve this exercise. Then exercise number 9, page 103. So before we start solving this exercise, let me say the following regarding the forces. Whenever we have a mass, then it will be directly subjected to the weight. Whenever we have a string or a spring, it will be directly subjected to the tension. Whenever we have a support, it will be directly subjected to the normal reaction. Okay, so now in 9.1, let me first read the given. Inclined plane. A solid S is resting on a perfectly smooth inclined plane, is attached at point A to a spring balance fixed at O. So this is the spring balance. Recall that the spring balance measures the magnitude of the force. So here the spring balance is measuring the force in the string. Now okay, so the string is in contact with the solid at the point A. Now in 9.1, name the forces that act on S. Because the solid S has a mass, then it will be directly subjected to the weight, as we have mentioned here. And because we have a support, this is the support, then it will be directly subjected to the normal reaction given by N or R, it's the same. And because we have a string, then it will be subjected to the tension T. These are the different forces acting on the solid S. Now in 9.2 they are telling me specify the characteristics of the force exerted by the string on S. So we need to list the properties of a force. Which force? The force exerted by the string on S. So here by the force by the string on S, so they are talking about the tension because the tension is due to the string. Then we need to list the properties of the tension. So the tension T we have the point of application, the line of action, the direction, and the magnitude. Now as usual we know because the tension T is classified as a contact force, so this will be the point of contact. And the line of action of the tension is always along the string. So one should always memorize these two and complete the missing. Then I will complete them in blue. Now the point of contact between the string and the solid S is the point A. So this is the point of contact A. Now along the string, so this is the line of action which is along the string. So in this case it is oblique. It's not vertical nor horizontal, it is oblique. And now as for the direction, so if it is oblique, it will be either like this or either like this. It is always away from the solid, which is like this. Moreover, it's preventing it from falling down, so it is upward to the left, sorry, upward to the right. And as for the magnitude is not given here. Notice that I'm not considering these yet, I'm just only in the first part. As for the magnitude, now the magnitude is not given in the exercise. The magnitude can be determined actually from the reading of the spring balance. So the needle is pointing at 8, and we don't forget to multiply by the scale because we are taking data from the graph or from the spring balance, which is given by 0.1. Then this is equal to 0.8. Since the scale is expressed in newtons, so this will be expressed in newtons. So this is the reading of the spring balance. Now, if you continue the part they are telling me, then represent it using the scale 1 centimeters corresponding to 0.5 newtons. And by represent, it means that we need to draw the vector. And in order to draw the vector, we need to determine the length of the vector. And the length of the vector can be determined using this scale. So knowing that each 1 centimeters corresponds to 0.5 newtons, what about 0.8 newtons? It corresponds to how much? So this is the missing value here, and it can be determined by using the crisscross. Then 0.8 multiplied by 1 divided by 0.5. And using the calculator, this is given by 1.6 centimeters. It is expressed in centimeters simply because this question mark, the unknown, is under the centimeters. Now let me here redraw the figure in order to represent the tension T. This is the support, and this is the solid S. Here we have the point A, here we have the point G, and here we have the point B, which is the point of contact between the support and the solid S, as indicated here. So the length of the tension represented from the point A oblique upper to the right is given by the tension T. It is worth 0.80 newtons, and according to this scale, its length is given by 1.6 centimeters. So this is the magnitude of the vector, and this is 1.6 centimeters. This dash here, just to show you that this is 1 centimeters, and this is 0.6 centimeters. Now we are done with parts 9.1 and 9.2. Let's move to the next part, which is 9.3. Now in 9.3 they are telling me specify the characteristics. Sorry, let me keep number 9.1 and just erase number or part 9.2. Now in 9.3 they are telling me specify. We are already done with the tension. Now specify the characteristics of the force exerted by the support S. So here it must be by the support on S. Now we are left with two forces, the weight and the normal reaction. Then the force exerted by the support on S is given by the normal reaction, because we know that whenever we have a support we have a normal reaction. So we are talking about the normal reaction. So let me eliminate this. And we have the following properties: point of application, the line of action, the direction, and the magnitude. And regarding the normal reaction, we know that because it's classified as a contact force, the point of application will be the point of contact. As the line of action, it will be perpendicular to the support. And we know nothing about the direction and the magnitude. Now we are ready to complete the missing parts. So I expect that everyone should understand and memorize the following regarding the normal reaction, as I have mentioned for the tension force. Now the point of contact, which is the point of contact between the support and the solid S, which is the point B. Perpendicular to the support, this is the support. So in order to determine the line of action of the normal reaction, we need to consider a line which is perpendicular to the support like this. But now I will erase this. So this is perpendicular to the support. In this case, the line of action is, so notice that I have represented this vector perpendicular to the support. Now notice that the line of action is not vertical nor horizontal, so it is oblique, and the direction, it is either like this or like this, but it always acts away from the support, so it is like this. Then the direction is upward to the left. So the line of action is oblique, the direction is upward to the left, and as for the magnitude here is given to be 1.3 newtons. Now they are telling me then representing it using the same scale, which is this scale. And as I have said, by represent it means that we need to draw. If each 1 centimeter corresponds to 0.5 newtons, what about 1.3 newtons? It corresponds to how much? So if we crisscross, now 1.3 multiplied by 1 divided by 0.5, this is equal to 2.6. Since this is under the centimeters, then it will be expressed in centimeters. What does this represent? This represents the length of the vector represented at the point B, which is the normal reaction. This is the point B, represented perpendicular to the plane like this, to the support. So this is the first centimeter, this is the second centimeter, and this is the 0.6. So this is 1 centimeters, and 0.6 centimeters. Now this is the normal reaction, and its length is given by 2.6 centimeters worth 1.3 newtons. This is it for part 9.3. Now in 9.4 they are telling me specify the characteristics of the force exerted by Earth on us, and for sure they are talking about the weight, and let's eliminate it. We need to list the properties. Then as for the weight W, we have the point of application, we have the line of action, we have the direction, and the magnitude. So always the first three properties for the weight are always fixed, and they are given by the center of gravity G. The line of action is vertical, the direction is downward. Now the magnitude, it will change from body to body depending on its mass. So they are telling us that the magnitude is given by 1.5 newtons. So we should only complete this. And as I expect that everyone should memorize these and understand them at the same time. Now we need to represent this vector using this scale, which is given by 1 centimeters, the same scale, because they are telling us here, then represent it using the same scale. So if each 1 centimeters corresponds to 0.5 newtons, what about 1.5 newtons? It corresponds to how much? So now if you crisscross, 1.5 multiplied by 1 divided by 0.5. Now plugging this fraction on the calculator, then it's given by 3. Since it is under the centimeters, then it will be expressed in centimeters. So now this is the length of the vector. Now we are ready to represent it because we know the properties and we know the length equivalent to 1.5 newtons. So from the point G vertically downward, so each one here represents 1 centimeter. This is 1 centimeter, 1 centimeter, 1 centimeter. This is the weight, 3 centimeters, worth 1.5 newtons. So this is it for this exercise. Now let me move to the other exercise in chapter 6, which is page 117, number 5. They are telling us relationship between weight and mass. So now the magnitude of the weight W of a body is linked to its mass by the formula weight is equal to M multiplied by G. Find each term in the formula by referring to the triangle below. So putting our hand over W, then W is given by M multiplied by G. Putting our hand over M, then M is given by W over G. Putting our hand over G, then G is given by W over M. Now remember that mass must be expressed in kilograms, and in order to convert from grams to kilograms, we divide by 1000. Now in 5.1, they are telling us calculate W of a body of mass M is equal to 200 grams on Earth. Let G is equal to 10 newtons per kilogram on Earth. So we have the mass, we have the gravitational field strength or acceleration. We need to calculate W. So W is equal to M multiplied by G. No need to construct a triangle because this is the formula that we want. Now the mass is given by 200 grams. In order to convert from grams to kilograms, we need to divide by 1000. Then this is equal to 0.2 kilograms. Okay, then 0.2 multiplied by 10, which is the value of G, then this is equal to 2 newtons. So the weight is equal to 2 newtons. Now in 5.2 they are telling us calculate the mass M of a body given W and given a G corresponding for the moon and the weight on the moon. So we need to calculate M. Now W is equal to M multiplied by G, and you are interested in determining the value of M, then constructing the triangle of this formula, W at the top, M and G at the bottom, covering M with our hand, then M is given by W over G. So W over G. Now the value of W is given by 112 in the SI, and the value of G in the SI is given by 1.6. Plugging this on the calculator, then it's given by 70. Since everything is expressed in the SI, weight and G, then the value of M will be expressed in the SI, which is kilograms. So M is equal to 70 kilograms. Now in 5.3, a body of mass M is equal to 2.5 kilograms has a magnitude of weight 9.25 newtons. On Mars, calculate the gravitational acceleration G on this planet. So we need to calculate the G knowing the mass and knowing the weight. Then weight is equal to M multiplied by G. So we need to calculate the G. Then constructing the triangle of this formula. Here we have multiplied and weight be at the top, M and G at the bottom, covering G with our hand, then G is given by W over M. Now here we need to make sure that the mass is in kilograms. Yes, it is. So 9.25, which is the value of W, divided by the value of mass, which is 2.5. Plugging this on the calculator, then it's given by 3.7. Since W and M are expressed in the SI, so the value of G will be expressed in the SI, which is in newtons per kilogram. Then the G is equal to 3.7 in newtons per kilogram. And one should memorize the value of G, the unit of G, which is given by newtons per kilogram. And if you forgot, try to refer in the exercise to a value of a G, and you can notice that in all of the cases G is expressed in newtons per kilogram. Then that's it for me in this video, guys. In the next part 6, we'll complete solving exercises on this chapter.